Hi everybody, this is Tim Urdan, author of Statistics in Plain English, and in this video I'm going to show you how to perform a multiple regression in R and get the descriptive statistics and correlation matrix as well. So if you're familiar with R, this should be pretty straightforward, the R console. If you're not familiar with R, you might want to take a look at another video that I made that's called Descriptives and Overview of R, to give you an idea about how these windows operate in R. All right, so up here in this top left window is where I have the code or the script for how to run a regression. So first thing that I'm going to do is I'm going to select the data that is going to be used in this regression. And here we're going to, out of the larger data set, we're going to pull out the ID variable. That just is the ID numbers for each of the cases. Self-efficacy, wave 3 self-efficacy, wave 3 English grade, wave 3 family, and wave 3 value. So these data were collected from a sample of high school students, and I collected data over multiple waves. So in this analysis, I'll be using data from the third wave of data collection. Self-efficacy, right here, refers to confidence in one's ability to do the work and to understand the material. All of these questions were about their English class, so this is going to be referring to confidence in doing well and understanding the material in English. Wave 3 English grade is the grade that students received at the end of the semester. Wave 3 family refers to family orientation. This is thinking about the family as reasons for doing well in school. So wanting to make the family proud, wanting to be in a position in the future to take care of family members, that kind of thing. And then this variable is value. This is valuing of the work in English. Thinking the work in English is important, thinking that it's interesting, thinking it will be useful to you later, that kind of thing. So those are the variables that will go into this analysis. So I'm going to run that line to select the data. And then here is the line to get descriptive statistics for each of the variables that are in the analysis. So I'll run that. And we can see that we have the 4 variables. It doesn't do this for the ID variable. That just brings in the cases. So the sample size is 973. Here's the mean column for each variable, the standard deviation column, and we also get the median and minimum and maximum. I'm not sure what these trimmed numbers represent, so I'm going to skip over that. The range, skew, kurtosis, and standard error of the mean for each variable. So those are the descriptive statistics. Next, in this line here, we can ask R to give us a correlation matrix for the variables that are in the analysis. And you see down here that R actually produces 2 different tables. The first one is the table of correlations. So if you look here along the diagonal, you'll see the ones. That is each variable correlated with itself. And then if you look in this column, the wave 3 self-efficacy column, you can see how self-efficacy is correlated with each of the other 3 variables. And it looks like all of the correlations in this table are positive, so all the variables are positively correlated with each other, and that they are small to moderate in size, ranging from 0.06 to 0.32, it looks like. So not real strong correlations. Down here in this second correlation table, what you get are the p-values. So are these correlations significant? And you can see that almost all of them are statistically significant, except for this one. That was our smallest correlation between English grade and valuing of the work in English. That's kind of interesting just by itself. There's no correlation between how much students value the work in English and the grade they get in their English class. Not what I would have expected. But all the other correlations are statistically significant, and that's probably due in part to this being a pretty large sample, because even this correlation of 0.09 is, although it's very small, is statistically significant. Okay, so that's the correlation table. Now let's take a look at our regression. So this is the line in the script for running the regression analysis. So let's do that. And what you see is that first of all, wave 3 value is the dependent variable. So we're trying to see whether self-efficacy, one's grade in English, and a family orientation predict how much students value the work that they do or that they have in English. So here is information about the residuals. So you can see whether your residuals look like they are normally distributed. You can see the first quartile and the third quartile are pretty close to each other, and the median is pretty close to 0. So it looks like that the residuals will form a pretty normal distribution, which is one of the assumptions of regression. And if we go down here to the coefficients, you can see here's the intercept. So when all three of the predictor variables have a value of 0, the predicted value of y, which in this case is valuing of English, would be 1.4632649. And then here's the coefficients for the predictors. Self-efficacy is a positive predictor of value. The t-value for self-efficacy is right there, which is quite high, and it is statistically significant. This is the p-value. You can see that's looks like 2 to the negative 16th, and it also gives you these handy asterisks that show you whether the predictor is statistically significant. Here's the codes for these asterisks down here. So if you get 3 asterisks, that means it's significant at the 0.001 level. The second variable, or predictor, wave 3 English grade, is a very small negative predictor when you're controlling for the other predictors in the model of valuing of English work, and it is not statistically significant. And then family orientation, right here, is also a positive predictor of valuing, and if you look here, you can see that it is also statistically significant at the 0.001 level. So I can conclude that self-efficacy and family orientation are both significant predictors of valuing of the work in English. They're both positive predictors, and that's when controlling for the other variables in the model. The multiple R squared is here. The more familiar adjusted R squared is here. So about 12.57% of the variance in the dependent variable, valuing of the work in English, is explained by these 3 predictor variables. And then you get the overall F statistic right down here. And we can see that that is also significant. So the overall model is statistically significant. So that's it. That's how you perform a multiple regression analysis in R.